Let's look at this one here. We say a coil with 250 turns, and the area of that is placed in a magnetic field of that strength. Then the field lines are initially parallel. They are initially parallel, right? Initially parallel to the normal. The coil is then rotated in 0.3 seconds such that the field lines are at 40 degrees to the axis of the coil. Calculate the change in magnetic flux. Right. So we want magnetic flux when we are given Teslas, and this test TB 0.5. Magnetic field strength is 0.5 Teslas. So now we use the formula. It says magnetic flux is equals to the change in magnetic flux. So we want the change in magnetic flux. Yes, if we read the question, it says change in magnetic flux is equals to the final flux minus the initial flux. So I'm going to calculate the initial flux first. The initial flux is equals to BA cos theta. So initially they say it is parallel to the normal, which means this is the normal parallel. They said if this is the normal parallel, then the angle is 0. The angle is 0. Right. So the magnetic field is 0, strength is 0.5. The area is 150 millimeters. We don't want millimeters, we must convert that into meters squared. We don't want millimeters squared, we want meters squared. So I know that 150, to convert millimeters to meters, you divide by 1000. And because it is millimeters squared and we want meters squared, then we square the 1000. Square the 1000. So the area will be 1.5 times 10 to the power negative 4 meters squared. So I put 1.5 times 10 to the power negative 4. Then cos of, they said, is initially parallel to the normal. So normal parallel is 0. The normal parallel is 0. No trick about it, 0. So theta is 0. Calculate. Then we calculate final flux. The final flux is equals to B A cos theta. Then B we still have 0.5. The area we still have 1.5 times 10 to the power negative 4. Then cos of they said 40 degrees to the x-axis, which means it's normal. So 40, we said axis means normal. So now it means the angle is the normal 40 degrees. So we write 40 degrees as our angle. It is the normal 40 degrees. We are using normal 40 degrees. So that is cos 40 degrees. And then we get our final flask. So that is the final flask. Therefore, the change in magnetic flask said the final flask, which is 5,75 times 10 to the power negative minus 7,5 times 10 to the power negative 5 is equals to. So, yeah. So this is the change in magnetic flask. 1.75. 1.75. The next one is calculate the average induced EMF induced. So the average EMF induced. When we're looking for average EMF induced, it will be E is equals to negative N change in magnetic flux over delta T. Now this is negative 250. Then the change in magnetic flux we have it as 1, 1,75 times 10 to the power negative 5. Then divided by 0.5, 0.3. Right, then the answer is that one there. Then a coil with 400 turns in the area of 10 centimeters is placed in a magnetic field. The field lines are initially perpendicular to the plane of the coil. The coil is rotated. It's just the field lines are right. So now they say calculate the change in magnetic flux. So change in magnetic flux, the change in magnetic flux is equals to the final flux minus initial flux. So I first get the initial flux. The initial flux is equals to BA cos theta. Then this is 0,2. The area is 10 centimeters. 10 centimeters cube, and it must be converted to meters cube. So to convert centimeters to meters, we know that it is 100, but it is squared. so I must square. So now the area is 0,001. Then cos of, so initially we said initially it is perpendicular to the plane. So this is not the normal perpendicular because there's a plane. There's no normal, so, or there's no axis. The word axis is not there, and the word normal is not there in this statement here. So when they say perpendicular to the plane, which means they are not talking about the normal perpendicular. And because they are not talking about the normal perpendicular, so the angle is 0. It's 0, which means it translates to parallel, actually. Yeah, it translates to parallel. So this is equal to 0,0002. Meters. Then now we calculate the final flask. The final flask, using the very same formula, BA, using BA cos theta. This is the final flask. So this is 0,2. That's magnetic flux. This is 0,2. The area is 0,00. Right, then we look at the angle now. For the final fast, the angle there is what? 35 to the plane. So this is not the normal 35 because that way the weight normal is not them. All right, so this is not the normal, or the weight normal, or the weight axis is not there. When you see the weight axis or the weight normal, then it means that you are taking the angle as it is, normal as it is. So the weight normal is not there, which means now I have to change this to now I have to subtract from 90. So I say 90 minus 35 degrees. So you put 55 degrees because 90 minus 35 is 55. Right. So the final answer is 0, 0. Sorry, the final 0, 1, 4, say 1, 5. 115 Webers. Then you subtract the 2. Right, so change in magnetic flux is equals to the final flux 0,000115 minus 0,00 02 02 is equal to 0, 0, 0, 0, 0, 85 Webers.